Hello guys, welcome you all for this end-to-end session of data science where you're gonna learn everything like artificial intelligence, machine learning, deep learning, data analysis, generative AI, NLP, everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying and we are learning a lot. Guys, I hope like same thing for you guys. Okay, so if you guys have any doubts, any stuck that you stuck anywhere, just ping in the comment section. We will take up and we will solve your doubts. Okay. So let's dive into today's session. Today's session is a coding session. I'm very happy. Like whenever it is a coding session, like for me, most likely like more than a theory, I will understand the theory. But like when I used to have a coding, right, I can able to visualize whatever the things that I have learned. Okay. So I love this coding session. Let us jump into today's coding session. So today's coding session is all about PCA coding session. Hope you guys watched all the previous session videos. Please make sure if you guys doesn't watch, please watch all the previous session videos so that you guys can able to understand what we are telling. Okay, so that's the one thing. So for the past two sessions, we have gone through the PCA, that is principal component analysis theory part, as well as the black box of it. Okay, so let's go for this coding part. Okay, so today is the PCA's coding part. First thing what we're gonna do means I hope like guys, I know now you guys have memorized. If you guys are watching our videos, then this is gonna be, I think, I hope like it's gonna be 10 plus session. Okay, for coding. Now you guys already know what we're gonna do first. Okay, and before that, it's an ID. It's a Google Colab ID. So for this, we have explained this end to end in the Python session. Make sure you guys watch that session. Okay, let us go move for the today's session, coding part of PCA, that is principal component analysis. Importing necessary libraries. First is NumPy, where it is used to do the mathematical operation. Pandas, it is used. Sorry, it is used to do the. It is used to understand or have the data in a table format. Matplotlib.pyplot, which is used to visualize the data. sklearn.dataset, I'm going to use inbuilt dataset, that is a wine dataset, load wine. Then from pre-processing, I'm just using standard scalar. Then from deep composition, I'm just importing the PCA. This is how I can import the PCA. Okay, you guys can able to understand right now. Next, model selection, I'm just importing the train test bed. Now I'm going to load the dataset. So load wine is used to load the wine dataset. My x is all the data, wine.data. Y is my target value. That's it, wine.target. So this is my entire dataset. You guys can look into it. We are having an array for data, and then target value 0, 1, 2, and then target class is 0, 1, 2, and I think the features are like I think the alcohol range, that like those things, I think so. Like let's see what we are having. So yeah, alcohol, malic acid, ash, and then magnesium, like total fluence, like flavors, like different things out there. Okay, these are the composition which says, yeah, this wine belongs to class 0, this wine belongs to class 1, this wine belongs to class 2. Okay, you guys can able to understand based on these features, it's gonna say which class it is belong to. So my x, okay, if this is my x. I hope like these are the things, that is alcohol content, magnesium content, ash content, like those things it is saying. And this is my y, so 0, 1, 2. So whether it belongs to class 0, 1 or 2. Now moving on, let's print our x data. That is, I'm just passing this x to the data frame, pd.data frame, and then I'm just giving the value, like column value, wine.feature names. That's it. Alcohol, malic acid, ash, magnesium, like those things we are having. Okay, continuously we are having different things, line. Okay, like different things we are having. I say nearly like 13 columns we are having, 13 features that we are having. Okay, and there are 178 records. Hope you guys can able to understand where from where I'm just telling. See here. Okay, rows or records, 178 records, whereas we are having 13 columns, that is 13 features we are having. Now moving on, let us summarize our data set. df.summary, like df.describe, it's gonna throw us the descriptive statistics about our data. You can see here, we are having dataset summary. So alcohol, the number of counts we are having, and then the mean value, standard deviation, minimum value, maximum value, 25%, 50%, and 75%. So different things we're gonna have. So that is what the, for the alcohol column, we are having a different value, that is a descriptive statistics we can say. Okay, just using a single word, describe. Okay, next, df.shape, you guys can see here, this is what the shape we have already discussed about it. Okay, we are having 178 rows and then 13 columns. That's it. Okay, you guys can able to understand. Now moving on, we're gonna pre-process our data set. Okay, the reason is, you can see right in this data, you can see alcohol we are having 2-digit number, malic acid we are having a 1 point digit number, here 0 point number. So as a human itself, and here you can see 3-digit number as a human itself, and here it is 4-digit number, man. We will give high importance to this 4-digit number. Model will also think this is a column that is majorly important. No, not like that, right? So we need to make the model generalized, and it should learn everything. So what I'm doing means I'm gonna standardize it. That is, to some range, I'm gonna get all the data and I'm gonna scale it up. Okay, like -1 to 1, -2 to 2, -9 to 9, anything. Okay, you just see here how I'm gonna do means I'm just loading the standard scalar. It's a model to the scalar variable. Scalar dot fit transform. I'm gonna give my input x, so it becomes the scaled x scaled. So I'm gonna just print the result. That's it. Okay, first 5 rows we are having. Okay, so this is what I think here, everything in the range of -2 to 2. Okay, because like it depends on the data set, guys. Okay, I think for the wine data set it is like -4 to 4. Okay, it can be anything, but like all the values in all the columns, it's gonna be same scale. Okay, rather than having a 4-digit number in one column, 2-digit number in another column, 0.1 digit in another column, not like that. Every column gonna have the same scaled data, so that the model gonna treat them similar. Okay, let's move on to the next thing. Okay, I'm gonna split my dataset into train and test. So x scale, this is my input, y is my output, and then I'm just using the test size as 0.3. That is 30% of data for testing and 70% for training. And then I'm just using the random state equal to 42, so that whoever just run this code, right, they're gonna get the same answer. Now I'm gonna load the PCA, that is principal component, and then I'm just giving the components as 2 and components is 2. That is, we are having a dimension of nearly 13 features, converting these 13 features to only two components, that is 2 features. So I'm loading the PCA model with n components equal to 2, and I'm gonna fit transform. That's it. Okay, I'm giving only training data. Why I'm giving only input, guys? Can you anyone able to understand why I'm only giving input? Just ping in the comment section. So I'm gonna say the answer. Okay. Okay. What is the answer? Because it's an unsupervised learning. We only need to give only input. Okay, and model will predict category wise, and then we're gonna map them whichever thing that we need. Okay, hope you guys can understand why we doesn't have output, because unsupervised learning will not have the output. So I'm just giving only my input. So fit transform PCA, that's a model, fit transform of x train. So I'm gonna have the xPCA. So you guys see here we are having only 2 dimension. The 13 features, that is malic acid, alcohol, like methyl content, magnesium, everything convert to only 2 features, which can represent the entire data set of 13 features. Now I'm going to see below. So this is my x train, this is my input, and only one input. You guys see here. Here, just count, guys. This is the actual data set that we have had. For each and every row, we will be having 30 features. See here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 feature. For this 13 feature, we have done a PCA and makes it 2 feature. And you guys see here, we are having only 2 features. These 2 features represent these 13 features. Okay, guys, this is a way that we need to understand each and every algorithm. When I have explained you theoretically the black box kind of thing, I hope like how many of you able to understand or not. Now you guys should have understand this. Okay, hope you guys can enjoy this. Okay, so this 2 dimension of PCA, which makes us to explain this 13 dimension. Okay, now you guys tell me, computation for this 30 dimension will be high, right, when compared to only 2 dimension, and storing this 30 dimension data very high when compared to only 2 dimension, right? Now you guys can able to understand, right? These are the advantages of PCA that we are just discussing in the last 2 sessions. Okay, moving on, let us print the explain variable ratio, variance ratio, that is PCA component. PCA is a model name dot explain variable ratio. That's it. You see, we are having variable ratio, that is first component we are having, right? This 0th column, first column. This 0 is principal component 1. This is principal component 2. That's it. So principal component 1 able to crack from the 100% 36% of information gain, whereas for the principal component 2 we are able to crack information of nearly 18%. So nearly we are getting from 100% we are getting 36 50 54% of data we have gained. It's a loss, right? We are having nearly 46% of loss. So as we are explaining, right, so that I am just explaining you, okay, but this is not the case. You guys at least need to have a PCA nearer to 95. 5% error is okay, but it also depends on the domain. Guys, if you go for a medical domain, don't do that. Don't go for the PCA, because it's very sensitive. You should not lose any of the information, okay. So try to make data gain or information gain around 95, okay. But here we are having only 54. There is lots of information loss. As I'm just explaining it, I'm just saying that it is this much loss is there, okay. Now moving on, I'm just printing the y train, okay. This is the training data that we are having. You can see 0 1 2, okay. Now I'm going to visualize it. Let's see how to visualize it. XPCA, that is my input, which is converted to a principal component, and I'm just printing the first dimension of it, that is 0th dimension, okay. Guys, 0th dimension means it's gonna represent that is a principal component 1, that is principal component 0. Now I'm gonna have the principal component 1, that's it, okay. We are having principal component 0 and then principal component 1. I'm giving a color of y train, okay. This is what the training data, because we're gonna have three classes, right? We're gonna have three classes: the class 0, class 1, and class 2. That's it. Based on the features, it's gonna say what kind of wine class it is, okay, whether it is 0th class, first class, or second class, okay. When I gonna print it, let's see, before that I'm just creating a scatter plot. My input is x PCA of 0 dimension, and then x PCA of first dimension, and then y train. Now I'm just printing the first principal component in X label, second principal component in Y label, and then my title is PCA on the wine dataset, but it is in the training set, only training set. I'm just showing it off. Guys, see here. It's not like a magic. We had a 13 dimension data. Is it right? 13 dimension. Can you guys able to visualize first of all 13 dimension? No, right? Now we are having only 2 dimensions, so that we can able to visualize. You guys see here, we are having a first principal component here, second principal component here, and you can able to see 3 different classes in this, right? This is how we can do, guys, okay. We are able to one thing I will say, we are able to visualize a 13 dimensional data, okay. It's a achievement for us, right? Yeah, let's move on to the next coding part. Yeah, now I'm gonna pass x test, okay, to this PCA, so that he can also able to create only 2 dimension. These 2 dimensions represent the text data's test data that we are having, right? Those 13 features. Do the same thing. Let's do the same thing. So this is what the test data for the, and then I'm gonna have the only one data from the test data, and let's see whether I'm having that. Okay, wait a minute. So yeah, this is what the 13 features that we are having in the test data, and this is the PCA converted test data. Only 2 features, which these 2 features which represent all the 13 features that we are having. Okay, wow. So I hope like you guys are able to understand. Now, yeah, y test, which is the y test data, that is the output. I'm just having 0 1 2, a combination of it. Same thing I'm gonna do, but for the test data. 0 dimension, first dimension. Now my color, C is the color. Earlier we have done something like y train. Now we are giving like y test. That's it. That's the only difference that we are doing. Okay. First of all, we have just applied our training data to PCA and makes our 30 dimensional data to only 2 dimensional data, and we have visualized. Now we are giving our test data of 30 dimension and making it only 2 dimension, and now we're gonna visualize it. Okay. So X label we are having first principal component, Y label we are having second principal component, and our title is PCA of wine dataset, one test. Okay, I'm just printing it out. Guys, see here. It's not like a magic, guys. We are just doing step by step. Okay, we are having first principal component, second principal component, and we are having all the 3 different colors. This is 3 different classes that we are having in the wine data, and PCA of wine data test set. Okay, we have seen the train set and we have seen the test set. So that's all about this session of coding, guys. Hope you guys have enjoyed. Okay, I have enjoyed a lot. Okay, so yeah, this is how we can able to reduce the dimension of a data from max, that is a high dimension, to low dimension. And I want to include one more thing. Now I have reduced my data set only to two dimension. Now take this data set and apply any algorithm that you need. Since it's a wine classification algorithm, apply the classification algorithm only to these two columns. Have this as the input, and the corresponding output what are there. Okay, have these two as the x, and your y is 0 1 2, any one of the classes. Okay, you can just predict it and go for the classification, any kind of classification model. So now this results become the pre-processing step. Okay, hope you guys have enjoyed. I have enjoyed a lot, guys. So yeah, this is all about the coding part of PCA. Hope like sir is gonna give some more insight onto it. So yeah, sir, over to you.
Yeah, guys. So if you have come to this session, so guys, go and watch all the session 5 to 10 times and do reinforced learning, absorb the information, digest, and apply. Mimic this project, do as it is, and imitate it, and do all the quizzes. Keep learning deeply. So, PCA, we have to, step one, we have to import all necessary libraries, NumPy, Pandas, Matplotlib, load the dataset, standard scaler, PCA, train the test split. So we have to import all these libraries. Step 2, loading the dataset. We have to load wine equal to load wine, x and y. Wine.data, wine.target. Okay, let's move to the other section. So we got the output. Yeah, step 3. So we got the target variable as output, and then x array, whatever, this is the output, and then y array, this is the output. Then step 3 is summarizing the data set, and we have to summarize df equal to pd.dataframe x column equal to wine.features name. So this is how you will get the summary. You'll get an overview, feel of data, that how it looks like. Okay, so let's go to the step 4. Then we get the summary, dataset summary, with print dataset summary, then dataset shape. So this is the shape, and this is this summary and shape. So this is how it looks like. And shape is 178.13. Then we have step 4, which is pre-processing the data set, and we have to scalar equal to standard scaler, x scaled equal to scalar dot fit transform x, print n first 5 rows of the scale data, x scaled 5. So this is after we do standardization, so that we get the output. You can have a feel and look of it. And then we go to step 5, splitting data set into optional for train and test purpose, x train, x test, x y train, y test, and equal to train test split, x scale y text size equal to 0.3, random states 42. These would be random states. Okay, so then we have got step 6, applying PCA will reduce dimensionality to two principal components for visualization. So PCA equal to PCA and components equal to x PCA equal to PCA dot fit transform x train. So x PCA, you will have array. Okay, then we go to x train array. This is the output. Then we have x train 0. Then we have x PCA 0. Okay, and that is array will be -3 3.0 to 0.48, and print the n explained variance ratio PCA component, PCA dot explained variance ratio, which is Explain variance component is 0.36 to 0.1, yeah, 8. Then extrain, we have the output. Then step 7 is visualizing the PCA. So here we'll visualize the PCA first and second principal component. Okay, on wine dataset. So first, second principal component, and then the wine dataset. And first one principal component you have from x and y variable. So x and y axis you have first principal and second principal, and actually the data of wine dataset is, which is training set. So this is how you can see the first principal component, second principal component, how data looks like, how is the visualization of it. Let's move to the step 8, transforming test and visualizing the optional x test PCA equal to PCA dot transform x test. So then we do x test PCA array is this. This is how it will. So actually PCA will transform from higher dimension to lower dimension considering the most important information. That's the main logic. Okay, what we are doing X test. This is how it looks like. Can we go down? Yes. Then we have X test 0 array. This is how it looks like. Then we have X test PCA 0. This is the array, and then Y test. This is how it looks like. Then we are going to plot figure, and we'll do plot scattered, X label, Y label, title. So first principal component, second PCA with wine data set. So again we'll see how it looks like. It is different than what we did with training. Now test data is different. There is difference. Okay, let's move.
Yeah, sir, that's it.
Okay, so keep learning deeply, guys. Mimic this and imitate this project. Apply, and like you have absorbed the information, you have digested. Digestion, how you do digestion? Like you reflect on it yourself. Once you receive information, you reflect on, you process it, and then apply. Here with these applications, projects, you can apply, mimic, imitate, and then do all the quizzes, write to us, and do all the assignments. So this is how you will learn 360-degree, and you will never forget. You will always continuously learn. Have that mindset. Keep learning deeply. Thanks a lot.
Yeah, guys, so this is all about the coding session of PCA. Hope you guys have enjoyed. We have enjoyed a lot, and we have learned a lot from this coding session. So yeah, guys, that's all about today's session. Make sure you watch entire session. If you guys have any doubts, just ping in the comment section. We will take up and we will solve your doubts. Okay. So yeah, guys, thank you guys. Thank you so much for all your support, and keep learning. Happy learning. We will all meet in the next session. Bye, guys. Take care. Bye.